Hello everybody, and welcome back to another Big Ideas lesson. Today, for Algebra 2, we are talking about section 4.2, how to add, subtract, multiply polynomials. What we're going to learn today is how to add and subtract polynomials. Here's a spoiler alert, it's a lot like how we do it with the quadratics, and also how to multiply polynomials. So, let's get to it. With adding polynomials, our goal is to combine all like terms across the polynomials. So like terms are where they have the same variables and exponents, and there are a couple of different ways to do this, but we're going to show you both. One way is to do it in what we call a vertical format. Do you remember back when you were in elementary school and first learning how to add together numbers like these? Maybe we had something like 632 plus 46. Well, you learned to do it in a vertical format. You would just add up all the proper digits. You would add your 1's together to make 8, you add your 10's together to get 7, and you'd add your 100's together to get 6. And if there wasn't something there, you'd just carry it down. It's the exact same way with polynomials. All we need to do is stack them on top of each other and combine all the like terms vertically. Now, the most important thing is to make sure that they are in standard form. As a reminder, from 4.1, standard form is when they are in order from highest to lowest degree. So we'll say that they're in order from the highest degree. So, is this in standard form? Well, it looks like our highest degree is 3, and it's in the front, so that's in standard form. And this one, the highest degree is 3, and it's in standard form. So we're good to go. Next, we stack the two on top of each other with the like terms in columns. So the key is that we want to have all of the like terms on top of each other. Notice how here we have our x cubed on top of each other, and our x squareds, and our 1's. If a polynomial is missing, so like this one doesn't have an x term, we leave a blank space, just like how we leave a blank space when we're doing normal vertical addition. Last but not least, all we need to do is start combining our like terms. So what is 3x cubed plus x cubed? Well, 3x cubed, adding another x cubed in there, is 4x cubed. Next up, we have 2x squared plus negative 10x squared. Keep in mind that negative does travel with the 10x squared. 2 plus negative 10 is negative 8. So it's negative 8x squared. Our negative x is by itself. It doesn't have anything to add to, so we're just going to take it down and put it here. And what's negative 7 plus 8? Negative 7 plus 8 is just positive 1. So our answer is here. Perfect. If this method doesn't sit right with you, you can also just do it in a horizontal format. Horizontally just means, hey, make sure you're combining like terms, but you have to be very careful because doing it horizontally, there's no way to check spatially if you're doing it right. So let's take a look. First off, we want to add 9x to the 4th to something. So we check and see if there is a 4th degree term in this second polynomial. And would you look at that? We have negative 2x to the 4th. So we can combine like terms. 9x to the 4th plus negative 2x to the 4th is 7x to the 4th. Next, we take a look at the next one. Do we have any other x squared terms in here? There's an x squared we can add here, but there's no x squared term here. So that just means we're going to take this and we're just going to put it in our answer since there's nothing to combine it with. I'm going to put it right here to leave a space for any x cubed terms we might have. Can we combine negative 2x with anything in the other one? Well, yes, we can. Negative 2x can combine with negative 5x. Negative 2x plus negative 5x is negative 7x. And last but most certainly not least, we have this negative 1. Are there any constant terms in the next polynomial? There are. There's a 12. So negative 1 plus 12 gives us plus 11. Make sure you check the second polynomial to see if there's anything else that needs to be carried over. Notice how we never added this 7x cubed term because there was no x cubed over here. That just means that we're going to have to put it into our polynomial as well. Plus 7x cubed. And we're done. Subtracting polynomials is much the same. To subtract polynomials, you can do the same thing, putting them in vertical or horizontal format. But please be super careful. This is something that a lot of people miss. If we're subtracting two polynomials, we're not just subtracting x cubed minus negative 6x cubed. We're subtracting everything in the second polynomial. So this would be negative 5x squared minus positive 7x squared, x minus positive 2x, 3 minus negative 9. To get around this, my recommendation, something that I personally do, is I like to distribute the negative and turn it into an addition problem. So if we just distributed this negative across, negative 6x cubed is just 6x cubed. And negative 7x squared, negative 7x squared. And negative 2x squared will give us minus 2x there. And negative 9 is plus 9. So you can transform a subtraction problem into an addition problem by putting that minus sign on everything, and it makes the problem a little bit easier to manage. Instead of having to worry about subtracting everything, we just worry about combining them just like we did the last one. So x cubed plus 6x cubed is 7x cubed. Negative 5x squared minus 7x squared is negative 12x squared. X plus negative 2x is going to give us negative x. 3 plus 9 is 12. And you could have just done it with subtracting as long as you remember to subtract each of these terms. The same rule applies if we're doing it horizontally. We can take this negative and we can put it onto everything in the second polynomial to make our lives easier. This would be the same as writing out x to the fifth minus x to the fourth plus 3x cubed plus 1. Instead of minus, we could write it as plus negative 3x to the fifth, because we distributed the negative here, minus 2x to the fourth plus 2x plus 6. These two are the same, I just distributed my negative to everything here. And of course, when we start combining our like terms, we have our x to the fifths, so that's going to be negative 2x to the fifth. We have negative x to the fourth plus negative 2x to the fourth, that's negative 3x to the fourth. We have our 3x to the third here, but nothing here, so we'll just put 3x to the third. We don't have a squared term in any of these, so we can leave that blank. We have a 2x over here, so I'm just going to write plus 2x, and 1 plus 6 is 7. On the next page, there's some practice for you to try out. Feel free to pause the video and try out these practice problems. I'll be here when we come back. Try out these 6 problems. They look the same, but one's addition and one's subtraction on either side. How'd you do? Remember that a lot of these are easier to do in standard form. If you can put these in standard form, it'll make these a lot easier. Something else that might make problems easier, let's say we have like a long problem like this one here, is that every time you put a term down, cross it off in the original problem. So like 8n to the fourth was by itself. I put it down, so I'm going to cross it off so I don't forget that I've already used it. 12n to the third by itself, so I can cross it off after I write it down. To do 3n squared, it's 4n squared plus negative n squared. I cross both of those off. When we have our 2n and negative 2n, we cross those off because they make 0. Negative 7 and 8 gives us plus 1, and we can see that we missed nothing. Next, on to multiplying polynomials. So, to multiply two polynomials together, we're allowed to use FOIL when we have binomials. The problem is polynomials aren't that small. Polynomials have a lot more terms than just 2. We can't just FOIL it out. We need to generalize it to handle much larger strings of numbers. So, here's our rule. To multiply two polynomials, multiply each and every term in the first polynomial with each and every term in the second polynomial. Then combine like terms. This can be done horizontally or vertically. We're going to see it both ways. So, just like how you learned to multiply numbers back in elementary school, where you might have, let's say, 12 times 14, we know the process. We know that you're supposed to multiply our 4 by 2 and 1. Then you're supposed to multiply the 1 by 2 and 1, and you would get your answer. Everything multiplies everything. So just like that, we're going to do the same thing down here. If we have negative x squared plus 2x plus 4 times x minus 3, we can multiply them by multiplying every term in one of them with every term in the other. So I'm going to start off by multiplying negative 3 times 4, giving us negative 12. Negative 3 times 2x, that's negative 6x. Negative 3 times negative x squared, that's positive 3x squared, right? Then we have to multiply our x by everything. X times 4 is 4x. Notice that I'm putting it under the x instead of under the negative 12, so I can combine them later. X times 2x is 2x squared. X times negative x squared is negative x cubed. So let me rewrite this because I wrote it a little bit small here on the side. I should have really done it over here. We would get 3x squared minus 6x minus 12 is one of the things we're adding. And the other one is 4x here. There's a 2x squared here. And there's a negative 3x, or sorry, negative x cubed here. All I have to do is just combine like terms. We get negative 12 here. Negative 6 plus 4 is negative 2x. 3x squared plus 2x squared is 5x squared. And negative x cubed is here in the front. This is our answer. I recommend doing this if you have a lot of space, unlike how I provided in the notes, that was very little space. But you can also multiply it horizontally. You remember how to FOIL. We're going to basically be doing that, except it's not really FOIL. It's multiplying the first term by everything, then multiplying the last term by everything. So let's start off by multiplying y times 3y squared, n times negative 2y, n times 2. Well, y times 3y squared is 3y cubed. Y times negative 2y is negative 2y squared. Y times 2 is 2y. Then we multiply the second term by everything. Our second term is 5. So we can multiply it out. 5 times 3y squared, that's just going to be 15y squared. 5 times negative 2y is negative 10y. 5 times 2 is 10. Now we just combine our like terms, and we're done. There's a 3y cubed that doesn't go with anything else. Negative 2y squared and positive 15y squared make positive 13y squared. 2y plus negative 10y is negative 8y. And our 10 is all by itself. There you go. So this is just like we did with quadratics. Getting practice with this is going to help you multiply quadratics as well. Last but not least, there are a couple of shortcuts that you are allowed to use as well. Sometimes when you're multiplying polynomials, it's a lot easier just to memorize what they're going to look like. And we've learned a couple of these. For instance, we've already learned that a plus b times a minus b is a squared minus b squared. Remember how we factored using the difference of squares? This is the trick that lets us do that. So if you had like x plus 3 times x minus 3, both the same first term, both the same last term, it's just they're added and subtracted, we can just write it as the first term squared minus the second term squared. For the square of a binomial, if you have a plus b squared or a minus b squared, you can follow these rules. It's the first term squared plus 2 times the first times the last in the middle plus b squared at the end. We learned this pattern from when we did our completing the square. These are our perfect square trinomials. And if it's a minus b, it just changes the sign here in the middle to a negative sign. One that we have not learned yet is the cube of a binomial. For instance, if we have x minus 1 cubed, the pattern says the answer will be this mess. It's a little hard to see, but let's actually see it out. We could multiply out x minus 1 times x minus 1 times x minus 1, multiplying all three of them together if we wanted to. We could do multiplying these two together, and then at the end multiplying that with another x minus 1. So like x times x is x squared, x times negative 1 is negative 1x, negative 1 times x is negative 1x, negative 1 times negative 1 is plus 1. We could just have this multiplied by x minus 1, but that seems like a lot of work, doesn't it? We'd have to multiply everything by x and everything by negative 1, after combining like terms, of course. Instead, the pattern says it should be, because we have x minus 1, it's a negative, a cubed, so it's your first term cubed. Well, our first term is x, that's our a value. Our b value is the negative 1. So it's x cubed minus 3 times a squared times b. Well, it'd be minus 3 times a squared. A squared is just x squared, and b is 1, so it's just x squared times 1, or just x squared. Next we have plus 3ab squared. It's going to be plus 3 times a, which is x, times b squared. Well, b is 1. That means b squared is still just 1, so we can leave it like this. Minus b cubed. Well, 1 cubed is 1. There we go. These are patterns that I recommend you memorize. They're worthwhile to memorize, but like I said, you can just multiply them out bit by bit otherwise. Let's flip the page. As you will see, there's a couple extra practice problems. I want us to try to multiply the polynomials using a method of your choice. You can use the patterns if you like. You can use vertical multiplication, you can use horizontal multiplication, whatever. And I want you to take a stab at question number 3. It's a little bit more of a thinking problem, but we now have the means to solve it. Try these 6 problems here, and then try out challenge 3 if you're ready for a challenge. We'll talk about all of them in just a moment. So pause the video and go for it. How'd you do? With this first one, I showed you how I recommended doing it, with just multiplying it horizontally, making sure the x gets multiplied to everything, the 2 gets multiplied to everything. When you have multiple multiplications to do, you might have to do 2 of them together, and then multiply that next one at the end. This one I used just a pattern. It's our sum of squares. Here, this one was probably the longest problem to do. You could have used the method where you multiply the first everything in the first term by everything in the second term. It was just a long problem. This one, we can use the difference of squares pattern, and here we can use another pattern to solve. But what about this one? What about example 3? Use the fact that the volume of a prism is given by length times width times height to find the volume of this prism. Well, we're given the length, it's 2x plus w, or plus 2. We're given the width, x plus 1, and we're given the height, x plus 3. So to find the volume, can't we just do 2x plus 2 times x plus 1 times x plus 3? I think we can. So let's work through this one together. Let's multiply the first 2 terms together. You can multiply whatever terms you want. I'm just going to multiply the first 2 together first. So I can use my trick here to know that I'm going to multiply 2x by everything and 2 by everything, giving us the following. 2x times x is 2x squared. 2x times 1 is just going to be 2x. But 2 times x is also going to give us 2x. So we would get a total of 4x. 2 times 1 is just 2. Next up, we can multiply, once again, everything in the first by everything in the second. So I'm going to multiply 2x squared by x and 2x squared by 3. I'm going to multiply 4x by x and 4x by 3. And I'm going to multiply 2 by x and 2 by 3. This one's a little longer, so I'll write this one all out and we can simplify it later. 2x squared times x is 2x cubed. 2x squared times 3 is 6x squared. Next up, we've got 4x times x is 4x squared. 4x times 3 is 12x. Last, we've got 2 times x is 2x. 2 times 3 is 6. So let's just combine like terms. What we'll end up seeing is 2x third, or 2x to the third power is all by itself. 6x squared and 4x squared combine to make 10x squared. 12x and 2x make 14x. And we have 6. That's the volume of the prism. V equals that polynomial. Thank you for watching, everybody, and I hope you have a fantastic rest of your day. Take care now.